Today we're going to demonstrate how MapMasq can help state, county, and local governments share location-enabled health data while protecting privacy. So let's get started. Many state, county, and city governments have access to protected health information. This information, if made available to others, could give valuable insights through location analytics and visualization. Many organizations already have access to ArcGIS Online or ArcGIS Portal, which is a platform for the sharing and collaboration of location information. This existing infrastructure would allow you to share information with public safety, emergency responders, healthcare providers, and even among state, county, and local government departments. However, the privacy requirements of the Health Insurance Portability and Accountability Act, or HIPAA, rightly prevent open disclosure of information. Additionally, ArcGIS Online is not a HIPAA-compliant environment. In order to share the information, it must first be de-identified so that it can be put into a non-HIPAA compliant environment. This is where MapMasq can help. By first using MapMasq to mask the data, de-identified representative data sets can be created that are no longer PHI and can be stored and shared outside a HIPAA-compliant environment. MapMasq aims to de-identify data to protect privacy while minimizing the loss of the analytical value of the data. So what does MapMasq actually do? It takes discrete data points and masks the spatial locations. It does this by randomly distorting data while attempting to preserve the spatial patterns. It will support aggregation into bins, and it will support aggregation into the bins based on census populations also. I do want to stress though that MapMasq is a calculator. It is not an easy button to HIPAA compliance. MapMasq uses the expert judgment rule within the HIPAA regulations. Depending on your data set, location, sensitivity, and your HIPAA compliance auditor, you may or may not need to apply additional or other methods. Links to published studies on these methods can be found at mapmasq.com in the resources section. First, let's look at triangle, square, and hexagon bins. Using these bins, you can clump data or cluster data without distorting the data too much and be able to aggregate it at a much smaller level. On the left, you will see some point data, which is your protected health information. The toolbar you see is the easy-to-use MapMasq interface. In this case, the user can pick from triangle, square, and hexagon bins, and adjust the size of the bins based on the extent or sensitivity of the data. This allows the user to customize the bin size to meet the HIPAA requirements established by their organization. On the right, you can see what a 2 square mile hexagon bin looks like on the city of Austin. Next, let's look at what some call the numerator rule. Using census geometries to determine the boundaries, the numerator rule simply states that for a release of information, you're required to have at least a certain number of events or occurrences per geometry. In this case, we said we need at least 15 cases. MapMasq will begin with the smallest census geometry in the area and merge them until a minimum of 15 occurrences are achieved. Now let's take a look at one that's a little more intriguing, which is the denominator rule. The denominator rule states that you must have at least a certain number of the underlying demographic population. This information is pulled dynamically from the census. Please note that no data ever leaves your local machine. The only information sent to the census is the extent of the data and the parameters you are looking for. All data and processing is done locally to ensure the PHI stays protected. In this particular example, the data is only looking at adult males, and the criteria used to establish the denominator reflects that. You'll see males 18 and or older, and we decided in this case we wanted a denominator of at least 15,000 males in the underlying population that meets that criteria. This is the real power of tying your data to census boundaries. In addition to actually going through this process, we save the actual underlying population. So in this case, that first polygon has just over 17,000 males 18 years and older. From this, you can derive percentages and rates and other information that might be relevant to what you're studying without having to actually pull the census data and do that yourself. So now let's look at rounding and truncating coordinates. It is exactly what it sounds like. We simply round or truncate the coordinate of the data point and reset it. The value of this over the simpler bin analysis is that the point level data is retained and not just a count of points. Essentially, the system stacks the points so that there's less loss of information. You can tell this by creating a heat map of the process results. However, for some end users, this format is less helpful than a nice visual grid that the bin analysis creates. Now let's look at the most sophisticated statistical method that we currently employ, which is called k-mean neighbor. It's also been called the donut method because of how it works. You can read more about that at MapMasq.com in the resources section. What k-mean neighbor does simply is it considers the distance to the points around it to determine how far it must be moved to achieve de-identification. The k value is the number of points you want to consider. Because of the properties of a gamma distribution, 5 is a common value you will find in published articles on the use of this method in health research. MapMasq takes this one step farther by allowing you to scale the results to be more conservative by specifying a larger final k-score average. In the example on the screen, we said we wanted the average to at least be between 10 and 12 on a final k-score. In the case on the screen, less than 1% of the points achieved a 0 k-score, meaning this data set has a minimal risk of re-identification. However, if your data set has clustering, achieving no points of 0 k-score is next to impossible. But keep in mind, HIPAA does allow for some risk. It does not have to be 0. As you can see, the final result is representative of the original data, but not a single point is on the original location, and 99% of those points crossed over at least one other point. The data set on the right, which is the process data set, we call that a representative data set that has been de-identified. This means you can actually share this data and process this data depending on the sensitivity and the need for the data. MapMasq licensing for state government is done in a special arrangement. We actually will give an enterprise license to the state government with one single purchase. Every single state, county, city, and those sub-entities of police, fire, as long as they are a government within the state that is a sub-entity of the state in some kind, we will allow them access to MapMasq under that one enterprise license. The state would be responsible for distribution of those codes though, so you can have as many of those as you need for those entities, but you're responsible for distributing them. It does not provide licenses for any federal, university, education, commercial, other users in your state, except in cases of declared emergency or natural disasters, and we can talk about that if the situation arises. You will need ArcGIS Professional or ArcGIS Pro before using MapMasq, except for the API version if that's something you're interested in. That's all we have for today. Thank you for watching the video. If you have any questions at all, please go to mapmasq.com or email us at mapmasq@gisinc.com, and we will get with you and talk about the details of how much it would cost for your state, other questions you might have, or other functionality that might be available. Thank you.